Okay, so hello students, just a minute, let me check if I'm live or not. Alright, so I think we're going fine, and hello students, how are you all? I hope that everybody is fine, and I welcome you all here at the very amazing platform Unacademy. So I am Ritika and I am a chemistry educator. So I welcome you all to the very amazing chemistry class at Unacademy, wherein we are here to ace our ICSE board exams with Unacademy Plus. Now students, what is this Unacademy Plus, and how is it helping to improve your performance? I will be telling you, but for that you have to stay here, and today it is going to be a very important session from your examination point of view. So I hope you stay here to learn a bit. Now before that, hello Avinash, hi, good afternoon. So I welcome you all. First of all, my name is Ritika. I am a chemistry educator. I have completed my engineering in electronics and communication, and also been awarded grade A in Cambridge English. And now talking about our session today. Okay, Avinash, namaste. I hope that you're fine. Okay. Yeah, I guess we are good to go now. So as we were studying the gas laws, today it is going to be a very crucial session. Why? Because today we will be applying all the learnings that we had till date. That is, we are going to have some important questions. Okay, so we will be solving these questions. Okay, and it would be very nice if all my students solve with me, and you also help me in knowing the answers. Okay, so it is a very active session today. So I request all of the students to grab a pen and paper and be ready. Okay, I'm very fine, Avinash. Thank you. Come on, let's move forward. So before starting our session, there's a request, students, that you can follow the Unacademy Champions channel on Telegram. So the link of this channel is provided to you in the description box. And why to follow this channel? Because over here you will be getting the daily information of all the sessions going on, of all the batches. Thank you, Avinash, for following. Also share this link with your friends. Okay, so you will be getting the daily information, the batches, the discounts, the offer prices, everything. So for that you need to be on the channel. And also subscribe us on YouTube. So it's a help that I need from you. So please share this video, please share this channel with your friends, and let us target 1,000 subscribers. You can also press on thumbs up button if you like the video. You can subscribe and press the bell icon so that you do not miss out the amazing sessions that go on here at Unacademy. Okay, alright, so let's begin study of gas law. Now what we will be doing, we will be having a quick revision. Okay, so that if there is anything that you have missed out, you will get the things would get clear, and then we will be moving on to our question session. So there are a lot of questions, okay, and numericals especially. So let's see how many students give me the correct answers. Okay, so let's revise. First of all, matter. Okay, what is matter? It is anything that occupies space and has a weight or mass. Okay, now if I talk about the states of matter, we have solid, liquid, and gas. Now this is the state of matter. Yeah, this chapter has numericals and also some of the give reasons question, Avinash. So we'll be focusing on both, but obviously more on numericals because they will be carrying a higher weightage. Okay, so let's see first of all a bit of what do we say, description of gases. Okay, so if I go for characteristics of gases. So the first is, the gases, they neither have fixed shape nor volume. Okay, now what is this? If I take any, if I'm having a fixed amount of gas, okay, and if I'm keeping it somewhere, so there's no fixed shape of a gas. Okay, solids, they have got a perfect shape, like this is a pen, this is a solid, so it has got a perfect shape. If I talk about liquids, they do not have any perfect shape, but they take up the shape of the container in which we pour them, right? But the gases, they do not have any shape or volume. Okay, now the molecules, like how we can say, or if the question is asked to you that give reasons why gases, they do not have any fixed shape or fixed volume. So what happens is the molecules of a gas, they are very separated, they are far apart from each other. Okay, and because they are far apart, what happens, the force, intermolecular force of attraction, for example, this is one molecule, this is another. So since the particles are very scattered, so this particle, it is not able to attract this one, right? So therefore the force is very less, and therefore the molecules, they can fly. Okay, and therefore we can say that it doesn't have a fixed shape or volume. So if we put a gas into any container, it will be taking the shape, or it will be occupying the whole container. Okay, next, gases, they are, just a minute, yeah, gases are highly compressible. Now what is the reason for the gases being highly compressible? So what is the reason? That they have maximum interparticle space. Okay, and because of the large intermolecular or interparticle space, what is the thing, that we can compress them, the molecules can come near and the volume can be decreased. Okay, so volume is decreased. Correct? So this is the reason we can say gases are highly compressible. So these are the questions that can be asked in the give reason type questions, right? So or prove that gases are highly compressible, or why can we say that gases are highly compressible? So in that case, what your answer will be, that the gases, they are having maximum interparticle space between them. So because of the interparticle space being so large, we can compress them. And since we compress them, what happens, all the molecules which were first scattered here and there, they now come closer. And since they come closer, the volume, it is decreased. I hope this point is clear. Next is, they have minimum density. Okay, it is. Okay, so if I say minimum density, what do we mean by it? Yeah. So if I go for density, it is number of molecules per unit volume. Okay. Now, if I talk about gases, the molecules are very much scattered, right? So the number of molecules in any unit volume, it is very less. Okay. So they have minimum number of mass or molecules per unit volume. So that means what? It has got a very low density. Okay. And next is, they easily undergo diffusion. So we can say they easily undergo diffusion. Now what is meant by diffusion? Can I get the answer in the chat box? I'm waiting for the answer, students. So they, the particles of gases, they generally, readily they intermix with each other when we keep them in contact. Okay. So what is the reason? Because the interparticle space is very large. So can I get the answer? What is the meaning of diffusion? Okay, now for example, if I take a room spray, if I take a perfume and if I'm spraying it, what happens? Very soon you will be able to, okay, Avinash has given me the answer, mixing of two or more gases. Yeah, intermixing of two particles, it is known as diffusion. Correct, Avinash, thank you. So, if I spray a perfume or a room spray, what happens? Very soon we are able to smell the fragrance. Why? Because the particles of the perfume, the molecules of room spray, they have mixed with the molecules of air. And why is it happening? So, let me tell you. For example, okay, this is our medium. Okay. And I'm having a particular type of molecules over here, and these are the gaseous molecules, right, which are pretty far apart. Okay, now if I am taking let's say I'm taking perfume, okay, and I'll just change the color over here. So what happens? The molecules, they spread, okay, because they are gases, so they spread easily, and now you can see that both the air particles and the perfume molecules, they are now mixed, right? And that is why it is said that they can easily undergo diffusion, that is, they can easily undergo intermixing, right? I hope the properties of gases are clear to you. So these were some of the properties of gases. Now we will be learning about gas laws. Now, what are gas laws? These gas laws, they describe the behavior of any particular gas. Okay, and under what three conditions are there? Can I get the answer? What are the three conditions? What are the three conditions which govern the behavior of gases? Alright, please let me know. Correct, temperature, volume and pressure. Very good. So we have under known condition of pressure, temperature and volume. Okay, so these are the basic things, okay, which we should be knowing, okay, to tell about any gas. Okay, now these variables we are using, and then we are going to study various laws. Okay, all right, now let's move further. First of all, if I talk about the units of temperature, what is temperature first of all? Temperature, it is the degree of hotness of any gas, okay, like how hot a gas is. Okay, now if I talk about units of temperature, we generally use here degree Celsius or Kelvin. Okay, now talking about the relationship between degree Celsius and Kelvin, so if we want to have the temperature in Kelvin, what we will be doing, we will just add 273 plus or whatever the temperature is given to us. And similarly, for taking out the temperature in degrees Celsius, what do? We subtract the Kelvin temperature from 273. Okay, next is, okay, so this was unit of temperature. Next, talking about unit of volume. So volume we measure in, let's say, cubic centimeter, meter cube, milliliter, liter, etc. So these are the various, yeah. Okay, SI unit is Kelvin, correct. So these are the, just a minute, it's just L. Okay, so these are the various units that we generally use. And next, talking about units of pressure. So what is the SI unit of pressure? Please let me know in the chat box. So if I talk about unit of pressure, we have atmosphere, we have millimeter of mercury, centimeter of mercury and Pascal. Okay, correct Avinash. Alright, so these are the units of temperature, volume and pressure. And if I go for the atmosphere and mm of Hg, what's the relation between them? So 1 atmosphere, it is equal to 760 millimeter of mercury. So these relations are very important when we go for numericals. Okay, hope things are very much easy and clear up till here. Ma'am, please teach shortly or else we would not have time for polls. Okay, let's go fast now. Let's go for Boyle's law. We will have enough time, don't worry. Okay, so Boyle's law, it tells what? That first of all we need to have constant temperature in this condition. Okay, so it tells that volume, it is volume of any mass of gas, it is inversely proportional to pressure. Okay, so we write volume, it is inversely proportional to the pressure. Okay, now what is the condition that we can write? So V is inversely proportional to P, so we can write V is equal to into K, where K is constant. Okay, and if I transfer, what I can write, PV is equal to K. And from this I can get an equation that is P1V1 is equal to P2V2. So this is Boyle's equation. Correct? Okay. Then we have Charles' equation. So let's go on next page. Yeah. We have Charles' law. So Charles' law said that pressure of enclosed mass of any dry gas, it remains constant. Okay, what happens over here? Volume, it is directly proportional to the temperature. So if pressure is constant, then volume, it is directly proportional to the absolute temperature. So we can write V is proportional to T. We can write V is equal to KT, where K is constant, and by this we can write V upon T is equal to K. Now from this we can write V1 upon T1 is equal to V2 upon T2. Now this equation, it is known as Charles' equation. Okay, I hope things are clear. Okay. Next, if I talk about the standard temperature and pressure, so this thing is very important because we are having questions on this. So please remember standard temperature and pressure. So standard temperature and pressure, the values are 0 degree Celsius or 273 Kelvin, and for pressure it is 760 mm of Hg. Or we can write in this place 76 centimeter of Hg, or we can even write it as 1 atmosphere. Okay, then we have gas equation. So gas equation is nothing but a combination of Boyle's law and Charles' law. Okay, so according to Boyle's law, we can write V is inversely proportional to pressure. According to Charles' law, we write that volume is directly proportional to temperature. Okay, this is our equation 1, this is our equation 2. If I combine both the equation, what I can write V is proportional to 1 by P into T. Removing the proportionality sign, I have V is proportional, I'm sorry, we have removed the sign, just a minute. Okay, I'm sorry. So we were saying V is inversely proportional to pressure according to Boyle's law, V is directly proportional to temperature according to Charles' law. So if I combine it, it is okay, and if I remove the proportionality sign, I have 1 by P into T into K. Okay, and from this what I can write, P upon V, P into V upon T is equal to K. Okay, so this is what gives us the gas equation, that is P1 V1 upon T1 is equal to P2 V2 upon T2. Okay. Oh, I'm sorry. Yes, Avinash, I've corrected it. Okay. Alright. So this is our gas equation. Okay. I hope things are very much clear. This is also known as perfect gas equation. And now a very important information first before we move on to our question session. The students of ICSE board grade 9 to 12, this offer is for all of you, but this offer is just for like 3-4 days now. It's ending on 31st January 2022. The offer says that if you buy a plus subscription for 12 months and above, you will be getting the amazing extra 3-month K-12 subscription absolutely free of cost. And of course, you are getting flat 10% discount on purchasing this plus subscription for any duration. Now this offer, it is only valid for first 500 subscribers, okay? So kindly go subscribe, okay? You are getting whole 3-month subscription absolutely free of cost. So this is a very amazing opportunity, right? So students, please go and please avail this opportunity, okay? Now, let's begin with the questions. The first question says, at constant temperature, a gas occupies a volume of 2000 centimeter cube at a pressure of 740 mm of mercury. Find at what pressure its volume will be 500 centimeter cube. Okay, so I'm giving you options. Okay, and the unit is mm of Hg. Now tell me, you have 1 minute, what is the correct answer? Let me know in the chat box. And you have 1 minute for this, okay? So let's see how many of you do tell me the correct answer over here. Okay, so Avinash says it's C. We'll see if it is correct or not. Alright, so let's have the solution. So what do we have here? First of all, we have volume V1. It is given to us what? 2000 centimeter cube, right? Okay, and then we have been given pressure 1, that is P1. It is given to us as 740 mm of mercury. Correct. Now find at what pressure. So we need to find P2. Volume 2, it is given as 500 centimeter cube. Now what is the thing which is given here? At constant temperature. So when temperature is constant, which law do we apply? Please quickly give me the answer in chat box. When the temperature is constant, which law is applied? So we apply Boyle's law, correct. And Boyle's equation is P1 V1 is equal to P2 V2. Now what is our P1? 740. Then V1, it is 2000. Pressure 2 we have to find out, and volume 2 it is given to us as 500. If I transfer and take out the values, okay, so my answer will be 2960 mm of Hg. So that is my answer, which makes the point number C as the correct answer. So Vinash, yeah, you got the answer as correct. Okay, then we have our second question. Can we move on to the second question? Hope that is clear. The question is clear to you. Alright, so can we move towards the point number, the question number 2. Okay, Avinash says that it is 4. Nope. Avinash, what happened? What's the confusion? See, just calculate it. It will come out to 2960 mm of Hg. Okay, it's first of all 4. And just give me a thumbs up if the question is, sorted. See, 740 into 4. Yeah, 40 will be 4. Okay, I've corrected it. And here the answer will be 2960. I hope things are clear now. Okay, now let's move on to the next question. So I'll just write over here. Okay. Moving on to our second question. It says a gas occupies the initial volume of 400 centimeter cube at pressure Z. If the pressure it is changed to 5 atmosphere, the volume of the gas was found out to be 200 centimeter cube. Calculate the value of Z. So let's see, the values here are these are the values, and please tell me what is the correct answer. So please let me know the answer, and till that time I'm just writing the values which are given. So what are the values which are given to us? First of all, we have been given the pressure one, which is Z. So that is what we have to find out. P1 is equal to Z. Then V1, it is given to us as 400 centimeter cube. Then P2, it is given to us as 5 atmosphere. And V2, it is given to us as 200 centimeter cube. So please let me know the answer. It is A, B, C or D. Now see, first of all, okay, here what thing is not given? Here temperature is not given, so we will be assuming that temperature it is constant, right? Now, what to use when temperature is constant? Which law is used? Boyle's law, correct. So it says that P1 V1 is equal to P2 V2. So what's the answer? A, B, C or D? Please let me know in the chat box. Okay, so transferring it, we have 200 into 5 upon 400. So that is 2 and 2.5. So here the correct answer is 2.5 atmosphere, which is the option number D. Okay, so is this thing clear to you? Question number second. Yeah, I already sent it, and yes, your answer is also correct. Understood this one? Okay, so just have a look and then we will be moving on to our next question. Alright, next question says, at a constant temperature, a gas is at pressure of 540 mm of mercury. At what pressure its volume decreases? Please note, decreases by 60%. Okay, so I'm giving you the options. First is 1500 millimeter of Hg mercury. Next we have 1600 millimeter of Hg. Then we have mm of Hg, and D is 1250 mm of Hg. I hope the options are clearly visible on your screen. So please let me know what's the answer over here. Okay, so alright, so I got one answer as C. Okay, let us see if it is correct or not. Now, what is given to us? First of all, temperature is constant. So, which law will we will be using? Oh, you remember this question? Okay, it's constant temperature. So we use Boyle's law. Okay. Now, first of all, what are the things given to us? So initial volume, let's take it as X. Okay. Now what we have been told that 60% of the initial volume. So 60% of X, it will be equal to 0.6x, and it has reduced by 60%. So what will be the final volume? It will be equal to initial volume minus the reduction, so that is equal to 0.4x. Okay. Now pressure 1, it is given to us as, I'll just write here, P1, it is given to us as 540 millimeter of mercury, and pressure 2 we have to find out. Now again, according to Boyle's law, we have P1 V1 is equal to P2 V2. Now we have to find out P2. So what we will be doing, we'll just transfer it. So P1 into V1 upon V2. Now putting in the values, what is P1? 540. What is volume 1? Volume 1 is X. And what is volume 2? It is 0.4x. So X gets cancelled into 10. And what will be the answer? It will be 1350 millimeter of Hg. Is it clear, everyone? Okay, so I hope things are very much clear now. Let's move on to our next question. Can we move on to our next question? If things have been clear to everyone, just give me a thumbs up if you have understood this question, and we will be moving on to next question. So our next question says that 100 centimeter cube of a gas at 27 degrees Celsius, it is cooled to 20 degrees Celsius at constant pressure. Calculate the volume of gas at 20 degrees Celsius. Now I won't be giving you option, or okay, I'll give you options. It will be a bit easy for you. Now you have to tell me the volume. Okay, so your options are, first of all, we have these are your options, and you have 1 minute. Now let me write first of all what the values are given to us. So we have been given first of all volume 1, that is 100 centimeter cube. Okay, then we have been given T1, that is equal to 27 degrees Celsius. Now we have to convert it into Kelvin. So 27 plus 273, that is equal to 300 Kelvin. Then we have to find the volume. So of course V2 is unknown, and T2, it is equal to 20 degrees Celsius. So that goes 273 plus 20 is equal to 293 Kelvin. Now see, what's the thing that is given? Constant pressure. So since constant pressure is given to us, we will be applying Charles' law, which says that V1 upon T1 is equal to V2 upon T2. Now what's the value that we have to find out? V2. Okay, so let's put in the values. First of all, V1 is 100, then T1 it is 300. V2 we have to find out, and T2 it is 293. Now if I transfer it, 100 into 293 upon 300 is equal to V2. So here 0 gets cancelled, and it's 293 upon 3, which is equal to 97.67 centimeter cube. and that makes the option B as the correct one. Is it clear, everyone? Okay, so I hope everything is crystal clear till here now. Okay, can we move on to next question now? Okay, so I hope things are clear. Okay, and now we will be moving on to next question. Okay, next question says, hydrogen gas, it occupies a volume of 400 centimeter cube at a temperature of 27 degrees Celsius and normal atmospheric pressure. Find the volume of gas at 10 degrees Celsius at a constant pressure. Now please tell me the value, the answer here without any option this time. So let me know the answer in the chat box. Okay, till then I'm just writing the values which are given to us. So we have been given the initial volume, that is V1, it is given to us as 400 centimeter cube. T1 temperature is given as it is given to us as 300 Kelvin. Why? 27 plus 273. Okay, so that makes it 300 Kelvin. Then we have to find volume. So V2 is unknown and temperature 2, it is given to us 10 degree. So 10 plus 273 is equal to 283 Kelvin, and V2 it is unknown. So first of all, constant pressure it is given to us. Okay, which law will we be applying here? Hello Mohammed Uzair. Okay, so over here it is okay, yeah, so we will be applying Charles' law, that is V1 upon T1, because temperature is pressure is constant. So this is our equation. Vinash got the answer as 377.3. so let us see if it is correct or not. Okay, so putting in the values, we have 400, that is volume 1, upon T1 it is 300. Volume 2, it is something that we have to find out, and temperature it is 283. Now if I transfer it, I am getting the equation as 400 into 283 upon 300. Okay, now cancelling it, 4 into 283 upon 3. So 3 9s are 27, 3 4s are 12.33, and when we multiply 94.33 into 4, we will approximately be getting 377.3 centimeter cube. Okay, so I guess Avinash, your answer is correct. Perfect. So this is the answer, okay, of this particular question. Very good. Now let's move on to next question, again without option. Okay, so try to solve without option now. So question says, carbon dioxide occupies a volume of 336 centimeter cube at STP. Find the volume at 20 degrees Celsius at pressure of 700 mm of Hg. So STP, standard temperature and pressure. So what is our pressure one? It's standard pressure. What is standard pressure? 760 mm of Hg. Then what is T1? 273 Kelvin. And what is our volume 1? It is given as 336 centimeter cube. Then we have been given volume 2, we have to find out. Okay, pressure P2 it is given as 700 mm of Hg, and T2 it is given as 20 degrees Celsius. So 20 plus 273, that is equal to 293 Kelvin. So here we will be applying the gas equation. that is P1 V1 upon T1 is equal to P2 V2 upon T2. Let me know the answers. Now, if I put in the values over here, okay, our P1 it is 760, volume 1 it is 336, and temperature 1 it is given to us as 273. Okay. Now, next is P2, it is 700, volume 2 we have to find out, and T2 it is given as 293. So is this the equation that you're getting, everyone? Now, if I transfer it, so I'll just write it over here. Okay, so I'm writing the transferred equation over here. So the final equation, it is 760 into 336 into 293 upon 700 into 273 is equal to volume 2. Is it clear? Now, if you solve this equation, you will be getting volume 2 as 2.215 dm cube. Oh, I'm sorry, not this. Okay, so if you solve this, just a minute. Yeah, you will be getting V2 as 391.52 centimeter cube. So what's the answer you're getting? Please check it, cross check if this answer is correct or not. Okay, perfect. Alright, Avinash, so your answer is correct. It is 391.52 centimeter cube. Now let's take another question, which is 2.5 dm cube of dry nitrogen gas is collected at temperature of 27 degrees Celsius and a pressure of 740 mm of Hg. Find volume at STP, standard temperature and pressure. Yes, Muhammad Uzair, Avinash, both of you, your answers are correct. And this is the next question. I'm just writing the values and please let me know the correct answer. So here P1, it is 740 mm of Hg. Okay. Volume 1, it is given to us as 2.5 dm cube. And temperature, it is 27 plus 273, which equals 300 Kelvin. Then we have, we have to find volume. So P2, it is the standard pressure, which is equal to 760 millimeter of Hg. Volume we have to find out, and temperature it is 273 Kelvin. So let me know the answer. Okay, I'll just write the gas equation, that is P1 V1 upon T1 is equal to P2 V2 upon T2. Putting in the values, I have P1 as 740 into volume 1 is 2.5 upon 300 is my first temperature, and then P2 it is 760 into volume 2 is unknown and temperature it is 273. Transferring the values, I have 740 into 2.5 into 273 upon 300 into 760 is equal to volume 2. Now on solving this, we get volume 2 as 2.215 dm cube. Correct, Avinash, very good. So this becomes our answer. Very good. So I hope that you might have understood the question, the answers, everything. Are things clear to you, students? Okay. Now let us see some of the theory questions which could be, asked from this particular chapter. So your first question is, what is STP and what are its values? Okay. Now, what is STP, everyone? Please tell me. It stands for Standard Temperature and pressure. Can you tell me the value of standard temperature and pressure? What is the value of temperature? Come on, quick. Values are 760 mm of Hg, correct? 760 millimeter of mercury or 76 centimeter of mercury. Correct, Mohammed Hussain. Your answer is correct. It is 2.21. Very good. Now next question is, what is meant by STP? That is standard temperature and pressure, and what is the value? So temperature, it is 273 Kelvin. Alright, moving on to our next question. Define the behavior of gases in terms of molecular motion. Okay, so this is something that I'll be telling you over here. Now, what is the thing with molecules of gases? So here the molecules of gases, they are far apart. Okay, they are far from each other. Okay, so because of this, what happens? Their intermolecular force of attraction. What is the intermolecular force of attraction between gases? Is it large or less? It is negligible. Very good. And therefore, the molecules, they are in random motion. Okay, and they move in all the directions possible. Okay, understood this question, everyone? Alright, then moving towards the next question. Give reason why gases are highly compressible. Okay, so I'll be waiting for this answer. Why are gases highly compressible? Alright, so let's see why gases are highly compressible. So first of all, if I talk about the molecules of gases are far apart. Okay, so what does this mean? They have a lot of interparticle space. I can say the intermolecular space, it is maximum, and therefore we can bring them closer, bring the molecules closer, and when we bring the molecules closer, that means what? That we can compress them. Can be compressed. Okay, cool, understood? Alright, so let me tell you a very important thing, and then we will be having the question of the day. So here we are at Unacademy subscription features. So why Unacademy? Now, Unacademy provides you the amazing features. Okay, now some of the features that I am going to tell you is, first of all, you can learn from the comfort of your home. You will be having unlimited access to all the courses. Okay, you can see all the courses, and you will be taught by top educators of India at one platform. So no need to go anywhere. Then, not just regular classes, you will be having regular doubt clearing sessions also and answer writing session. So in these doubt clearing sessions, you will be told, as whatever doubts you have, they will be cleared. Okay, you can have one-on-one discussion with your educators. You can talk to your educators. You can clear your doubts. Then answer writing sessions. So these sessions will be covered, telling you how to write effective answers in your examination. Then there is exhaustive coverage of syllabus. So that means your syllabus will be covered. You will be having the mentorship or guidance of your educators, and all the study material, it will be provided to you in the PDF format. So that means you get all the PDF PDFs, okay, to refer whenever and whenever you need. Now, apart from the classes, over here in Plus subscription, we also have practice tests. So to know how much we are learning, how much we are able to understand and grasp, practice tests are very important, right? And we also have live test series and batch courses over here. Now, students, in the Plus subscription, you will be getting your daily practice section, weekly mock test series, live quizzes, daily MCQ, and subjective test series. So these are some of the features that you will be provided here at Unacademy if you go for Plus subscription. Now, how to go for Plus subscription? So first of all, you can choose the plans according to your preference. You can go for 6 month, 12 month, 36, 48, whatever you want to go for. Okay, and then you will be using my code in the referral code option over here. Okay, so here you will be entering my code, that is RITIKA CLIVE. Okay, you just enter your code and you will be getting a 10% instant discount. Now, talking about one more important information, that is the crash course batches. So as you know, your term 2 examinations are very soon going to start, right? So therefore, it's very important to start your preparations right away. Now, for this, Unacademy has brought up the crash course batches, okay? And one such batch, it is ACERS, which is all subject batch having the delivery language as English. Now, this batch, it is going to start from 7th of February, and over here, physics will be taken by Ayushi ma'am, biology will be taken by Shikha ma'am, and chemistry will be taken by me. Students of grade 9, there's an amazing offer here also, that if you subscribe for grade 9, you will be getting the subscriptions of grade 10, 11 and 12 absolutely free. Okay, so you are getting such an amazing offer, and also these crash courses, they will be very helpful to you. Why? Because they will be preparing you for your examinations. So kindly make sure you join the crash courses and also spread this news with all your friends so that maximum students can take the advantage of these crash courses. Now, Unacademy free special class. So students, these classes, they are absolutely free of cost and everybody can watch it. Over here, these are the special classes. Why? Because there are some special features of these classes. Okay. Now over here, you can have live interaction. Okay. We have various chats, emojis. You can talk to your educators. Okay. Then we can have live quizzes through polls. So what is polls? It is a kind of MCQ which is asked, okay, in your classes, okay, and you can compete with the students who are already present. Okay, now you will be seeing your leaderboards, like who has answered most answers correctly, what's the time duration, etc. So these all will be given to you in this leaderboard type format. Okay, so I'm sorry, there was a connectivity issue. So I was telling you that special class, right? So if I talk about special class, so you can even ask the questions using the question tab and you can get your doubts cleared. Okay, so these are some of the amazing features of Unacademy free special classes. Now talking about how to watch my special class. So for that, you need to first of all download the Unacademy Learner app. And when you open the app, you will be clicking on Get Started. Alright, enter your mobile number and enter the OTP and sign up using your email ID. Okay, so you will enter your name, your email address, your residence, your state. Okay, and then you will be selecting your goal. So in your case, the goal will be grade 6th to 12th. Okay, and then you will be selecting your class. Okay, and you will be selecting the language that you want to learn. That is Hindi, English, Hindi or English, whatever language you want to learn in. Okay, just select that. Now students, in the description of this video, there is a special class link. Okay, when you click on that link, okay, it will pop up as notify me, and you click on notify me. All right, and you will be getting notified just 10 minutes before the class, and you can use my code Avinash. Just wait there. That is RITIKA CLIVE. So this is my code which you can use to unlock the special class for free of cost. Okay, so now telling you the question for the day. Okay, the question that you need to solve. So it's a very easy question, and I hope I will be getting answer. So it is, a gas occupies 400 centimeter cube under 760 millimeter of mercury pressure. Find the pressure at which gas occupies 380 centimeter cube, temperature being constant. So that's the question. Please let me know the answers in the chat box. Yes, you have to solve it now. Come on, tell me. I'm giving you 1 minute. Alright, so see what's the values which are given over here. First of all, we have been given pressure 1, it is 760 mm of Hg. Then volume 1, it is 400 centimeter cube. Pressure 2, it's not given to us, we have to find out, and volume 2, it is given as 380 centimeter cube. Now tell me what law we are using and what's the answer. Okay, so since temperature is constant, we are using Boyle's law. Let's see what's the answer. So P1 V1 is equal to P2 V2. Alright, then we have 760 into 400 is equal to P2 into 380. Okay, transferring. That is equal to 800 millimeter of mercury. Okay, so that is the correct answer. Correct, Avinash. I hope all the students might have got to know whatever things we have covered today. So basically we had a quick revision of the gas laws. We did all the important questions. Okay. Okay, everybody is a student of the day, Avinash, but yeah, you gave the most answers correctly, so well done. Keep it up. Okay. All right, so let's meet in our special class. Okay, so students, download the Unacademy Learner app. You can get this app on Google Play Store or App Store. You can use all these features for free of cost by using my code, that is RITIKA CLIVE. Please use this code, unlock all these features, and take your preparations to the next level. We will be meeting in the next class, okay, in which we will be learning a bit more about various things. Till then, keep learning, keep studying, take care of yourself, and we will be meeting in the next class of the very amazing platform Unacademy. So let's meet in the next class. Till then, thank you.